Welcome to another deep dive. We love to dig into the more technical stuff, and you all send us some really interesting articles about this concept of event sourcing.
It is a fascinating topic.
Yeah, honestly, it kind of sounds like something straight out of sci-fi. Systems that remember like every single change ever made, every single event. Not just the current state of things. Is that kind of the gist of it?
Yeah, that's the core idea, like a perfect log of every action in the system. It's almost like having a time machine for your data.
Okay, a time machine. I like that. I mean, instead of just seeing the current snapshot, you can actually rewind and see how you got there. But why is that so important? Like, what's the big advantage here?
Well, imagine you're trying to debug some complex issue in like an online store. Wouldn't it be so much easier to see exactly what happens step by step to lead to that problem rather than just the final messed up state?
Yeah, that totally makes sense. It's not just about knowing what happened, but like the how it happened. Now, these articles you sent over use this. They use like a fictional online retail company as an example.
Yeah, they use it to illustrate how event sourcing works in a real world scenario.
So let's dive into this online retail example a bit. They talk about, this company and how it has different parts of its system that all work together when a customer places an order. So, you've got order processing, you've got payment handling and shipping, all these interconnected pieces.
Hmm.
But we're focusing specifically on the payments for this deep dive, right?
Right. The focus is on the payment system because that's where they've implemented event sourcing.
Okay, payments it is.
Yeah.
And they use this concept of a state machine to visualize how a payment moves through different stages.
Hmm.
What exactly is a state machine and why is it important here?
Well, a state machine, it's basically a way to represent how something evolves over time. So think of a payment, right? It might start as like pending, then it could transition to authorized, then settled, and so on. Each of these represents a distinct state in the payment's life cycle.
So it's not just that the payment is successful or failed, it's more nuanced. We're tracking all these different steps along the way.
Precisely. And the crucial thing for event sourcing is that each transition from one state to the next, like from pending to authorized, it triggers something called a domain event.
So it's not like that status just silently updates in the background. We're actually explicitly recording each of those transitions as an event.
Exactly. Each event is like a little time-stamped record saying, hey, this happened to this payment at this particular moment. For example, when a payment is authorized, a payment authorized event is generated and stored.
Interesting. So we're literally building a history of the payments journey through these events. But where do these events actually get stored?
That's where the event store comes in. It's a special kind of database that's designed to store these domain events in chronological order. So it's like a ledger of every single change made to the payment system.
A systems memory bank, keeping track of everything. Now, the article mentioned that their code uses a real-world event store called Event Store.
Yeah, it's a real world example of event sourcing in action.
Very cool.
Yeah.
Now, they also talk about how each of these payment things, are those the entities? Each one has its own unique identifier.
Right. Each payment entity, it's essentially a software representation of a payment, and it has this unique payment tide. And what's important is that each payment entity also maintains a list of all the domain events associated with it.
So by looking at that specific payment entity, I can see its whole history. Just by going through that list of events, that's super powerful.
It provides complete transparency and traceability of every action taken within the system.
Okay, so we've got our event store, we've got our payment entities with their unique ID and their event histories.
Yeah.
How does how does one of these payment entities actually get created in the system? Like what triggers that?
Well, let's say a customer is checking out on the online store and they choose to make a payment. That action itself would trigger the system to try and create a payment entity.
So it's the customer hitting that like pay now button or whatever that kicks things off.
Yeah, and that create action, just like any other transition in the state machine, it generates an event. In this case, it would be a payment created event.
So even that very first step, the birth of the payment entity, is recorded as an event in the event store. We're not missing a thing. And I'm guessing this payment created event would include things like the amount due and the unique payment tide.
Exactly. All the essential information about this new payment is captured right at the moment of its creation.
Okay, so we've initiated a payment, triggered a payment created event, stored it in the event store. Where do we go from here? What's the next step in the life of this payment?
The next logical step would be to authorize the payment. That means verifying the payment details with the customer's bank or credit card provider.
So before any money actually changes hands, we're making sure everything is legit. Does that authorization step also trigger an event?
Absolutely. Just like with the creation process, authorization also generates an event. So assuming everything checks out, a payment authorized event is generated and added to the event store.
And to the list of events for that specific payment entity.
Precisely. We're continuing to build that timeline of events, recording every significant change.
This is amazing. We've gone from this high-level concept of event sourcing to actually seeing how it plays out.
Hmm.
But I have a feeling we've only scratched the surface, right?
Oh, there's definitely a lot more to explore. We still need to dig into how these payment entities are actually represented in code and how the system ensures that all this data stays consistent and valid.
Well, I am ready for more. But first, we're going to take a very quick break. When we come back, we'll delve into those juicy technical details of event sourcing. Stay tuned. All right, we're back, and I'm ready to get into the nitty-gritty. Before the break, we were talking about how creating and authorizing a payment triggers these events. And the articles you sent have some code snippets in there, which I always appreciate.
Yeah, it helps to ground these abstract ideas in real-world implementation.
Totally. So let's walk through it. When a new payment needs to be created in the system, what does that look like in the code? What's going on?
Well, the code defines a payment created event.
Just like we discussed earlier.
Exactly. And this event object contains all the necessary information about the payment, the amount due, the unique payment type, all that good stuff.
Right. So the code's really mirroring what we talked about conceptually, representing these actions as these digital events. But before this payment created event gets written to the event store, doesn't the code need to make sure that the information is valid? Like you wouldn't want to create a payment with a negative amount, right?
Exactly. That's where those business invariants that we mentioned earlier come in. The code has all these checks to ensure the data makes sense.
So it's like a bouncer at the door of the event store, only letting in events that follow the rules. What kind of checks are we talking about here? Give me an example.
Well, for example, the code might verify that the amount due is greater than 0.
Right.
You can't create a payment for a negative amount of money. Or it might check that the currency is valid or that all required fields are present. Just basic beta validation stuff to maintain the integrity of the system.
Yeah, building those safeguards right into the system. Makes sense. Okay, so assuming our payment created event passes all those checks and gets added to the event store, what happens to the payment entity at this point?
Well, remember how each payment entity keeps that list of all the events associated with it?
Huh.
So when that payment created event is generated, it gets added to the list for that specific payment entity.
Okay, so we're building up that chronological history event by event. All right, let's say the payment needs to be authorized next. How's that handled in the code?
The code would initiate an authorize action on the payment entity.
And that, in turn, would trigger a whole nother set of checks, I imagine.
Of course.
What are we checking for this time?
Imagine someone tries to authorize a payment that's already been canceled. That shouldn't be allowed, right?
Right.
So the system needs to make sure the payment is in the right state for authorization to proceed.
We're following the correct steps in order. Can't jump from canceled to authorized.
Exactly. So only if the payment is in the correct state, which in this case is probably pending, only then would the authorization logic go ahead, and if the authorization is successful.
Then a payment authorized event is generated and added to both the event store and to the payment entity's event list, just like before.
Exactly. We're just building up that timeline, event by event, recording every change to the payment entity.
Man, this really shows how powerful event sourcing is. Having that complete transparent record of what happened. I mean, what are some ways this level of detail would be actually useful? Like, why do we care so much about this?
Well, think about it. Imagine you're trying to debug a problem with a specific payment. Instead of just seeing the current state, which might be confusing or misleading, you can actually rewind the payment's history by going through all its events.
It's like having security camera footage. You can see exactly what happened, when, and by who. So much easier to troubleshoot.
Exactly. It's not just for debugging either. This historical data can be super valuable for auditing, for generating reports, analyzing trends, even training machine learning models. The possibilities are huge.
Now, earlier we mentioned that this example uses Event Store as its event store. Are there other options out there? Like, is that the industry standard, or is there something else that people use?
Yeah, Event Store is a popular choice. It's specifically designed for event sourcing, but it's not the only game in town. You could technically use other types of databases like a traditional relational database or a NoSQL database to store events.
So there's some flexibility in how you actually implement the event store.
Yeah, and each approach has its pros and cons. Purpose-built event stores like Event Store are often optimized for the unique characteristics of event data. Things like the chronological order and the huge volume of events that you might be dealing with. Using a different type of database might require more work to ensure performance and scalability.
So the choice of technology really depends on your needs and your constraints.
Exactly.
So it sounds like choosing the right event store is a pretty big decision.
It is. It's a key architectural decision. You need to consider things like the volume of data, performance requirements, ease of use, even just the development team's familiarity with different technologies.
Man, I'm realizing event sourcing is more than just like a cool concept. It's a whole different way of building systems.
Yeah, it's a bit of a paradigm shift, but as we're seeing, it has the potential to offer these huge advantages in terms of transparency, auditability, and flexibility.
Okay, we've covered a lot already. We've seen how event sourcing translates into real code. We talked about those business invariants and even touched upon different ways to implement event stores. There's got to be more to this though, right?
Oh yeah, we've laid a solid foundation, but we've still got to explore things like how to handle really long event streams and this concept of projections.
Projections. Now that's a term I'm dying to learn more about.
Oh, wait.
All right, we're going to jump right into those topics after a quick break. Stick with us. We're back. And, before the break, you mentioned these things called projections, and I'm really curious to hear more about that. What exactly are projections?
Projections are super interesting. Remember how our event store keeps track of every single event, like every little change? Well, sometimes you don't need all that detail. You just want like a specific view of the data.
Okay, so instead of like sifting through every event, we can create these projections, these customized views, to focus on just what's relevant.
Exactly. Let's say you want to display a list of like all completed payments on a dashboard. You don't need to know every authorization attempt, every little state change along the way. You just need the key info about the settled transactions.
So a projection basically lets us create that streamlined view, kind of like creating a custom report tailored to a very specific need.
Perfect analogy.
Hmm.
And you can create projections for all sorts of purposes, like generating reports, feeding data to analytics tools, even training machine learning models. It's really about extracting the insights you need from all that raw event data.
So these projections are like derived from the events, but they don't actually modify the original data in the event store, right?
Right. The event store remains the single source of truth, the immutable record of everything that happened. Projections are just different ways of interpreting and presenting that truth.
Got it. It's like preserving the integrity of the event history, but still giving us that flexibility to use the data in different ways. Now, you mentioned earlier that one of the challenges with event sourcing is dealing with really long event streams. As the system grows, that event history can get pretty massive. How do projections help with that?
Yeah, replaying like a huge stream of events every time you need to access the current state can become a real performance bottleneck. Projections actually offer a solution to that by letting us create what are called snapshots of the state at regular intervals.
Snapshot. So instead of replaying like thousands of events from the beginning, we could just start from a more recent snapshot and only replay the events that occurred since that snapshot. That sounds a lot faster.
Exactly. Snapshots are like these checkpoints that let you basically fast forward to a known state without having to process that whole history every single time.
It's like taking a picture of the system at a certain point in time.
Right. And while we've talked about a lot of the advantages of event sourcing, it's important to acknowledge that there are some challenges as well.
I was just thinking about that. I mean, it all sounds great in theory, but actually putting event sourcing into practice in like a real world system, that's got to be tricky.
Yeah, one of the biggest challenges is just like the mindset shift that's required. Event sourcing asks developers to think about data differently, not as these static values, but as a series of events that shape the current state.
It's not just about querying the database, it's about understanding the history of how we got here.
Exactly. And then there's also the whole issue of versioning. Over time, as the system evolves, you might need to change the structure of your events or the logic that processes them. Managing these changes in an event-sourced system can be tough.
Yeah. Versioning always seems to make things more complicated no matter what you're working with. It's like trying to keep track of all these different editions of a book and making sure everything stays consistent.
Great analogy. But there are tools and techniques out there to help manage that complexity. For example, schema registries, they can help keep track of different versions of events and ensure compatibility.
Schema registries. Wow, it sounds like we could do a whole other deep dive just on that topic. But I think we've covered a lot of ground today. We've explored the core concepts of event sourcing, looked at some real-world examples, even touched on some of the challenges. What are like the key takeaways you want listeners to walk away with?
Well, I think the most important thing is that event sourcing really offers a different way of thinking about data. It's not just about storing the current state, it's about capturing the entire journey, that history. And that history unlocks all sorts of new possibilities for how we build and use systems.
It's not just about the what happened, it's about the how it happened. And that how can be really valuable for a lot of reasons.
Absolutely. And even though event sourcing does have some challenges, the potential benefits make it an approach that's worth exploring, especially for systems where things like transparency and auditability and flexibility are really important.
Well, I know I learned a ton today.
Hmm.
Thank you so much for sharing your expertise with us and walking us through this fascinating world of event sourcing.
My pleasure. And just remember, everything that happens, every little action, every decision, it all leaves a trace, a history of events. Event sourcing encourages us to embrace that history, to learn from it, and to use it to build better systems.
So well said. And on that note, thank you all for joining us on this deep dive into event sourcing. We'll see you next time for another adventure in the world of tech.